Okay, question number 3 is a bowl with circular cross sectional area and the height 20 centimeter is given to you in the figure 2. The bowl is initially empty and water start flowing into the bowl. When the depth of water is 8 centimeter and the volume of water in the bowl is V centimeter cube is modeled by the equation that is given over here. Given that the bowl or the water flows from the bowl at a constant rate of 160 centimeter cube per second. Find according to the model the time taken to fill the bowl and the rate of change of depth of the water in centimeter per second when the height h is equals to 5. For that question, what you have to do actually, so you can see in this figure what are the things that's given to you. Up to this point, the bowl is filled and this height is basically 8 centimeter. I don't know, either this is 4, this is 5, whatever this is. This is unknown, means in the form of variable h. But the height that is taken to fill that ball is basically 20 centimeter. It's given to you because when I fill the water in this bowl and it is gonna fill up to this point, the last point means that this one would be treated as full of the bowl, and for that why my height would be 20 centimeter. So my first step should be finding my volume when my height is 20 because I have to find the time taken to fill the ball. So I can see when my bowl is filled, height would be 20 centimeter. So consider this equation number 1. V is equals to 1 by 3. At the place of each, I have to plug 20. So it would be 20 square times by 20 plus 4. So 20 square times by 24 means 400 times by 24 dividing by 3 would gives you the answer of V. That would be 20 seconds. So my volume, sorry, not centi, a second actually, the unit for this volume is centimeter cube. So that would be 20 centimeter cube, 3200. Yeah, sorry, 3200 centimeter cube. Now I have to find the time when the bowl is filled and the rate for this time bowl is 160. So definitely I have to do volume dividing by basically the volume of this filled bowl dividing by the rate gives me the time taken to complete this bowl at the maximum height. So it is 3200 dividing by the rate that is given to me is 160. So 3200 dividing by 60 gives me 20 seconds. So as a whole you can see the rate or the time taken to fill the bowl would be 20 seconds. So T is equals to 20 seconds is the answer for this first part. Got it? Moving to the second one. It suggests that the rate of change of the depth of a water when height is equals to 5 centimeter. Now here you have to make a scenario in your mind. Actually what you have to do, you have to find the rate of change of depth of a water. So rate of change of depth of a water will be definitely dh by dt because h is height and t is time. So rate of change of height would be dh by dt. Two things are given to me. The first one, that is volume in this equation number 1, and the second thing is the rate. So I can use the chain rule over here. dh by dt can be written as dv by dt times by dh by dv. Why I did this? Because I know the value of volume, so definitely I have 2 times by its derivative. Also I know dh by, basically I will convert dh by dt into dv by dt times y dh by dv by applying the chain rule over here. So dv by dt is known to me, that is basically this thing, that is 160. Given that the water flows through a bowl at a constant rate, it means that this is dv by dt. It's given to me, that is 160. Clearly it's mentioned over here that this is the rate for this bowl when the volume is flowing at this rate. So dv by dt is given to me. So plug back its value over here, that is 160. dh by dv is unknown. I don't know whatever this is. Definitely I will calculate. So for example, this is marked as equation number 3 and I will calculate dh by dv first. V is given to me. V is 1 by 3 h cube plus 4 by 3 h square. Let me confirm this is right. Yeah, this is. So V is this one. I will calculate dV by dH, then I will make it reciproc. So dV by dH can be calculated by d by dH of 1 by 3 h cube plus d by dH of 4 by 3 h square. Just only use the property of derivation, nothing else. So it gives you 3 h square dividing by 3 by using the derivation rule, power rule of derivation, plus 8 by 3 of each. 3 can be taken as LCM, and at the numerator you have 3 h square plus 8 times of each, right? So this is what? This is my dV by dH, and I have to find dH by dV. So I will make it reciproc. dH by dV can be written as 3 dividing by 3h square plus 8h. This is the value of dH by dV. Plug back its value over here in this equation number 3. So dH by dt is 160 times by dH by dV. That was 3 over 3h square plus 8h. So I can see I have to check its value when h is equals to 5. It's given to me in this question. If you go back to confirm, I have to find the rate of change first. Then I have to fix the value of h, that should be 5. So when I choose the value of h should be 5, then definitely at every place of h I have to plug 5, right? So when you did 160 times 3, it would be 480. Whole dividing by 3 times by 5 square plus 8 times by 5. Hold on your calculator and find what you are getting. 480 dividing by 3 times by 25 plus 8 times by 5. Your answer would be 4.17. So that would be the answer for dH by dt. That's all.